Hello, this is Jacqueline, and I will be solving this differential equation via the Laplace method. Um, so here's the differential equation: y double prime plus 16y equals the step function u of t minus the direct delta function of t minus 1 with the initial conditions y of 0 equals 0 and y prime of 0 equals 1. So we will take the Laplace transform of the whole thing, and that'll give us this answer right here. We got this from the derivative formula, which is right here. So we get that the Laplace transform of f double prime, which is y double prime right there, is this right here. So translated to our equation, since y of 0 is just 0, we put 0 right here, and then we put minus 1 because y prime of 0 is just 1. And then 16y, the Laplace transform of that is just 16y of s. And the Laplace transform of u of t, the step function, is 1 over s, because so this is the table that we will also be referring to. Here is the Heaviside function. As you can see, u of t minus c is equal to this, but since c is 0, e to the negative 1 is, to negative 0 is just 1. So that's why we get 1 over s, and then the Laplace transform of the direct delta function is e to the negative cs, and since c is 1, it's just e to the negative s. Then we can rewrite this as we will factor out the y of s. So we get, and then we add 1 to both sides so that we can get y of s times s squared plus 16 equals 1 over s minus e to the negative s plus 1. Then we will divide each of these terms by s squared plus 16, and we get the terms a, b, and c that I have written right here. I will solve, I will do the inverse Laplace of each of these terms, and I will refer to them as a, b, and c. Here is a rule that we will apply for the second term, for the b term, and that states that if the inverse Laplace of f of s is equal to f of t, then the inverse Laplace transform of e to the negative as times f of s is equal to the Heaviside function t minus a times f of t minus a. But we will use this rule later. So here we'll take the inverse Laplace transform of this, and to do that, we have to separate this into partial fractions, which I have done right here. And then we take the inverse Laplace transform of each of these. So this one is just 1 over 16th cosine of 14. As we can just factor out the negative 1 over 16, and then we will just get s over s squared plus 16. And according to the table, that is the cosine function. So that's why we put cosine right here. And then 1 over 16s will just be 1 over 16 this times the Heaviside function u of t. Again here, the c would be 0, which is why we don't have we don't have an e here, so that's why it's a step function, just t. So the inverse Laplace transform of term a will be this right here. And then we're gonna move on to the second term, term b. And that is negative e to the negative s over s squared plus 16. We will apply the rule that I mentioned before. So we get that here's the Heaviside step function of t minus 1, and then we're going to take the inverse Laplace transform of f of s, which is 1 over s squared plus 16. A will be equal to 1, so that is why we have t minus a here and here we have the 1. And so this term will just be equal to 1/4 sine of 4t, because the sine equation, as you can see, has a on top and we have a 1 here. So we must modify so that it gives us what we want. So that's why we add the 1/4 in front of it. So this is the inverse Laplace transform of the term b. And then we will just get the inverse Laplace transform of the term c, which is the easiest one. It's the same as this right here, as you can see. So it'll also be 1/4 sine of 4t. Then we will combine our answers from a, b, and c, and we will get 1/16, the step function ut of t, minus 1/16 cosine of 4t. And then here, I forgot to mention that I added a minus sign because this was negative, like the term b was negative. So that's why we have negative u of t minus 1 times 1/4 sine of 4 t minus 1. We plug in t minus 1 in here. And then plus the 1/4 sine of 4t. Yeah, I forgot to mention that we plug in the t minus 1 and here. And then, so we know that the step function uct it's equal to ut minus c. It is written right here in the table of formulas that I'm using. So these two are equal. So I just rewrote these as u1 of t, and then also here u1 of t. I don't really think I have to write the 1, but I just did it. So u1 of t is equal to this. And that is all. This is the answer. The inverse Laplace transform of y of s was just y of t. So this is the complete answer to our equation.